Okay, last time we completed the topic of measurements. We'll be doing some past paper questions in next week, and today we're starting a new chapter known as kinematics. Now, what is kinematics? Study of motion. Now, it might look very simple, but I'm about to ask a very complex question. What is motion? How do we know if something is moving or not? Now, apparently, it seems like a very obvious question, a very simple to respond. But when we start answering this question, we feel that we are running short of ideas. How would we know if something is moving or not? So, answer. If an object changes its position and or distances with respect to its surroundings. If an object changes its position and or distances with respect to its surrounding, it is in motion. So this is how we can define motion, and we need surroundings. What are surroundings? Surrounding are frame of reference. Without using a reference, we can never tell if something is moving or not moving. For example, if you look around in your room right now, you might find the laptop or mobile phone or a cup of
Sir, can I
tea
be
or
excused for a second?
sorry.
Can I be excused for a second?
Yes, you can.
Thank you.
Now, if you see around in your room right now and you look at the things that are there, you will find that you can very easily tell which thing is moving and which thing is not. And why is that? Because you can clearly see the things that are moving are changing their position and distance with respect to the surrounding in the room. And things that are not changing their position, for example, laptop, cup, or the shoes that you're not wearing right now, or the pad, chair, you find those things not moving. But if you think for a second, isn't Earth moving about itself? Or isn't Earth moving around the sun? Like around sun, it is traveling at a huge speed of around several miles, up to 8 miles, 10 plus miles per second. And in about itself, the rotation that produces days and night, that rotation is around 1800 kilometers per hour. So 1700, 1800 kilometers per hour. So that is very fast. So even the things that are not moving are moving with respect to somebody who observes those things somewhere which is not on Earth. Then he or she will be observing everything in your room moving. So motion cannot be understood unless we define a frame of reference. And without frame of reference, we can never tell whether something is moving or not. And that is very, very uh, confusing sometimes. It does not make sense when we start understanding it. Once we do, it is very, very beautiful, very complex. And we can never say for sure if something is moving or not if we don't decide the frame of reference we are talking about. Now, if motion means change of distance, the first quantity is produced, speed. What is speed? Speed is rate of change of distance. Change of distance divided by time taken. Speed equals to distance divided by time. So that is the first formula for this topic. Distance is always measured in meters. Time is always measured in seconds. So speed will always be in meters per second. Units of speed. There are two units, meter per second and kilometer per hour. So if we have to convert meter per second to kilometer per hour, we have to multiply by 3600 and divide it by 1000. And to convert from kilometer per hour to meter per second, we have to multiply by 1000 and divide it by 3600. Okay. So actually, this is a factor which can be multiplied by 3.6 to convert from meter per second to kilometer per hour, and divide by 3.6 if you're converting from kilometer per hour to meter per second. Another easier way is if you remember that 36 kilometer per hour is actually equal to 10 meter per second. If you remember this thing, you can compare any meter per second to find kilometer per hour or any kilometer per hour to find meter per second. Okay, for example, x kilometer per hour and y meter per second. You can write them like this and then cross multiply and then find out any missing value. So if you remember 36 kilometer per hour is 10 meter per second, or you remember these factors, you can convert meter per second to kilometer per hour. Very rare I have seen this kind of question appearing in exam. Now, speed is distance divided by time. Now, when we talk about change of distance, and there can be um, different kinds of speed. For example, instantaneous speed. Instantaneous speed means speed at an instant is called instantaneous speed. Very commonly used examples are, for example, initial speed. What is initial speed? Speed at the beginning of observational period. For example, when we start to observe something, at the start of the observation, the speed is initial speed. Most of the students think that initial speed means speed at the start of the journey. It can be a case, I'm not saying that it is always wrong. If we start observing something when it starts moving, then yes, initial speed is zero because the object is starting from rest, and this is where we are starting to observe it. But if we observe an object which is already moving, then initial speed is not necessarily be zero. And it is not speed at the start of the journey. It is speed at the start of the observation. What is final speed? Final speed is speed at the end of observational period. Initial speed is represented by u and final speed is represented by v. Now, after this, there will be average speed. What is average speed?
Total distance divided by total time.
Good. Average speed is total distance traveled divided by total time taken. Now, what is meant by constant speed?
It's when I think distance and time is proportional, directly proportional.
No, actually, it is when, yeah, yes, that is one way of saying that, but we define constant speed as if an object is traveling equal distances in equal intervals of time, it is traveling with constant speed.
Okay.
Constant speed is also known as uniform speed. An object is traveling with constant or uniform speed if it travels equal distances in equal intervals of time, no matter how small. An object is said to be moving with a uniform speed if it travels equal distances in equal intervals of time. Now, variable or non-uniform speed. An object is traveling with non-uniform speed if it travels unequal distances in equal intervals of time, no matter how small. So, if an object travels equal distances in equal intervals of time, it is traveling with uniform speed. And if an object is not traveling equal distances in equal intervals of time, it is traveling with a variable speed. Now, to understand that, I'm giving you an example. For example, there is this tree. Okay. I hope you can see it, because sometimes green color is not very pickable. Okay, this is a tree. Now, beside tree, there are some cars. Okay, this is a car. Okay, do you see a car over there?
Yes, sir.
This is car seen from a drone or from a
Okay.
top. Okay, this is a top view of a car. Now, there are three of them moving. Okay, these are three cars. Car number 1, 2, and 3. This is car 1, car 2, car 3. Okay, they are moving with respect to the tree, and somebody recorded how much distance each car is traveling in a certain amount of time. Okay, I'm making a table. Here we go. This is the table. Now, this is time in second: 0, 1, 2, 3, 4, 5. Distance for car number 1 in meters, distance for car number 2 in meters, and distance for car number 3 meters. Listen, car number one has is at 0, and in 1 second it goes to 6. Another second it goes to 12. It goes to 18. It goes to 24. It goes to 30. Car number two, it starts from 0, goes to 2, then goes to 6, goes to 12, goes to 20, goes to 30. Car number 3, 0, 10, 18, 24, 28, and 30. Now, these are the distances recorded at regular interval of time. Now, tell me which car is traveling with a constant speed?
The first one, sir,
And what made you say that?
because it's increasing by 6 meters per second every second.
So you see that the distance is changing by 6 meters in every second. That's why this car is traveling with a uniform speed.
Yes,
Very rightly so. Which car is traveling with an increasing speed?
car two.
And what made you say that?
So the first time it's increased 2 meters, then 4 meters, then 6 meters, then 8, and then 10.
Oh, so you see that it travels more distance in every next second. That's why it is traveling with an increasing speed. Similarly, the third car is traveling with a decreasing speed. It travels a distance of 10 meters, then it travels a distance of 8 meters, then it travels a distance of 6 meters, and so on. It travels less distance in every next second. That's why it is traveling with a decreasing speed. Now, what we have to do is we have to sketch graphs for this thing. So I hope you have a notebook with you which has lines on it, and you have a scale so you can make a graph. So what you do is you make an x-axis and y-axis like this. Okay. You use a ruler for that. Okay. Now you make it 0, and at regular interval you make 1, 2, 3, 4, and 5 as time axis on x-axis, and on y-axis you take, you can take an interval of 5, or you can take an interval of 2 on each line. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and 30. So approximately you take like 15 lines to make your y-axis. Okay? So this is distance in meter. Now what you have to do is you have to make 3 of these graphs. Okay, now we have to plot the graph of each car here. So do you think you can do that on your notebook?
Yes, sir.
If you need the data, you can take a screenshot of this thing. Take a screenshot.
Okay, 1 second. Okay, I got it.
Okay. Now you have to make all three graphs, and then we will discuss that how the shape of each graph represents whether speed of the car is increasing or decreasing or staying constant. Okay, let's consider it as your homework. Okay,
Okay,
so we will discuss this thing on Monday.
okay, sir.
So thank you very much. See you on Monday.
Okay, assalamu alaikum.
Walaikum salam.